Hey Trig class, this is your final exam review, and we're going to be looking at several problems that I gave you on your final exam review sheet that I sent to you in your email. So let's go ahead and get started with just number 1 and 2 here. I know I may have gone over this in both of my classes, but um, I told you how to solve for x in this type of problem here. But I didn't say solve for the two angle measurements. And that's what these two problems ask you to do. Not just find x, but solve for the two angle measurements that are supplementary to each other. So, uh, just like we would solve for x, if these two angles right here, these are our two angle measurements, 3x plus 4 degrees and 2x plus 1 degrees. If those are supplementary, the way you would set this up is you would say 3x plus 4 plus the other angle measurement equals 180 because supplementary angles add up to 180 degrees. Okay, and then the next step would be, okay, let's just solve this thing. So we get 5x here equals 175 and x equals 5. No, yeah. It equals 35. There we go. The next step that you would take to figure out your two angles that are supplementary to each other that we're referring to in this question is just simply plug it back into each x's that you have. So for this one, 3 times 35 plus 4, and then, whoops, not there, here. Well, we can put parentheses around it. It's that many degrees. So that will give us 109 degrees. And then the other one, 2 times x, which is 35, plus 1, that will give us our 71 degrees that we're looking for, which is this answer right here. Okay, same goes with complementary angles, except right here, what you would do is you would set your equation to equal 90 rather than 180. And that's all I'm going to show you on these two. Now, these next couple of problems, I just wanted to remind you all that coterminal angles that I want you to find here, it says find the angle of least positive measure coterminal with a given angle. Anytime it says least positive measure coterminal with a given angle, it means I want the smallest angle possible that is between 0 and 360 degrees. Okay, and that's it. So you're going to take your angle measurement given to you, such as the 877 degrees, and you're going to subtract, if it's a positive angle measurement, you're going to subtract 360 degrees until you get something between 0 and 360. So here we are going to subtract this twice. Subtract 360 degrees twice. And then that will actually end up giving us 157 degrees. And you're done. That is an answer. And then same thing goes with the negative 61 degrees. But in this case, instead of subtracting, we're going to add 360 degrees. And then that gives us 299 degrees, which is this answer here. And that's it for these two. Okay, number 7 I put in this review just because I want to remind you how to subtract or add degree in minutes and seconds, those types of angle measurements together. So let's look at this. It asks us to find the measure of the third angle of a triangle if the measures of the other two angles are given. So these are the measure of the two other angles. And y'all should know by now that a triangle's interior angle measurements add up to 180 degrees. So what we're going to do first is add together the 48 degrees and 19 minutes to the 86 degrees and 22 minutes to get this right here. Let's see, we get 41 minutes here and 134 degrees. Okay, now we need to take this total angle measurement right here of these two and subtract it from 180 degrees. Well, this is what I wanted to remind y'all of, that 180 degrees, if we need to subtract an angle measurement that has minutes and seconds in it, just remember that 180 degrees is equal to 179 degrees and 60 minutes. Now, if we needed seconds, which we don't in this problem, go from here that 179 degrees and 60 minutes is the same thing as 179 degrees, 59 minutes, and 60 seconds. Okay? But we don't need this in this problem. But what we do need is this section right here. And I'm going to say let's subtract the 134 degrees and 41 minutes from this right here to get our answer, which is 19 minutes and 45 degrees. And we are done with that problem. Okay, now let's take a look at this one. We are asked in this problem, it says, okay, a tree casts a shadow 16 meters long. At the same time, the shadow cast by a 62 centimeter tall statue is 93 centimeters long. Find the height of the tree. What we have here are two similar triangles that are being stated. And my suggestion here is if you're not understanding it correctly, like if you just can't see it in your brain, what you need to do here, draw it out. Okay, so that's what I'm going to do. I'm going to draw it out. So we have this tree that's casting a shadow that is 16 meters long. Okay, and then that's one triangle. It's a right triangle. And we have this statue that's 62 meters, or no, centimeters tall, and it is casting a 93 centimeter long shadow. Okay, well, probably should have drawn that a little bit shorter there, but anyway. Here we are. These are supposed to be similar triangles. I know it doesn't look like it, but they are. Okay, 62 centimeters tall and 93 centimeters long in the shadow. Okay, and what we're asked to find is the height of the tree. Okay, so this is similar triangles where we put together the corresponding sides ratios, such as this side here, x, corresponds to this side here. The height of the tree to the height of the statue. So x over 62 equals, let's see, 16, the length of the shadow of the tree, over the length of the shadow of the statue. And like I said before in class, if y'all remember this, it doesn't matter if these two triangles have different units of measurement. As long as the triangle here have the same units of measurements for the height and the length, then you should be good. Same thing goes for the tree here. What our answer is going to end up being, because we are looking for the height of the tree, it's going to be in meters for the units of measurement. Okay, so let's solve this. Okay, so what we get is, we'll multiply both sides by that 62, and x is equal to, if you round it, it's going to be 10.7. That's meters. And that is one of our answers. There we go. And we're done on this one. Okay, I know we've been solving triangles here lately in class. That's the last thing that we ended up with, but they are not right triangles. So I want to put this in the review to remind you of how to solve some right triangles. So So to solve this triangle first, I'm going to start out with, let's see, the given information that we know. So this right here we know is this 68 degrees and 14 minutes. Oops, degrees, 14 minutes. And B measurement here is 17. Okay, now to solve this triangle, remember we need to solve for the other angle measurement that we do not know, and then the other two side measurements we do not know. So let's go ahead and start by just finding the angle measurement of A. So A is equal to, now remember on a right triangle, these two angle measurements are always going to add up to 90 degrees. So just take 90 degrees and subtract your given angle measurement, the 68 degrees and 14 minutes. Now if your given information is in degrees and minutes, or degrees, minutes, seconds, then I want your angle measurement that you are solving for here in degrees and minutes, or degrees, minutes, seconds. Okay, so please keep that format. This is going to end up being A is equal to 21 degrees and 46 minutes. Now, what we need to solve for is A and C. And if you remember, this right here, then you should be pretty good on this. Now, I've always said to, in what you solve for on your triangle and plug in here for as your angle measurements, use what is given to you, but in this case right here, we didn't have to solve our other angle measurement with any of the sine, cosine, tangent functions. So these are both exact measurements. So you can use either angle here. It does not matter. I'm just going to use what is given to us. Okay. So I'm going to say let's solve for our side A here. Our side A, how I'm going to solve for it with our given angle is this right here is our opposite side, and the angle A, or sorry, side A is our adjacent side. So what we're looking for is this function here, tangent. So tangent of our given angle, 68 degrees and 14 minutes, is equal to the opposite over adjacent side, which is A. Now solve for A. And whenever you're at this point, plug it all into your calculator and figure it out. So that is approximately equal to 6.8 kilometers. And now let's do the same thing or something similar to find side C here. Now again, with this given angle right here, I have this is my opposite and now this is my hypotenuse. So opposite and hypotenuse, I'm going to use my sine function. So sine of my given angle is equal to the opposite, which is 17 over adjacent, or sorry, hypotenuse, just C. So solve for C. And plug that into your calculator and you will get something like this, 18.3, and that's again kilometers. Sorry, I ran out of room there. But that is it on solving triangles. Right triangles, that is, because you will have a couple of solving oblique triangles. Here's another one of those word problems that we have that I suggest to draw it out. Okay, so it says a pendulum of length 14 inches swings 5 degrees 37 minutes to each side of its vertical position. What is the length to the nearest hundredth of an inch of the arc through which the end of the pendulum swings? Okay, so we have this pendulum that is swinging from its vertical here from side to side. a little further down. On each side of its vertical here, it is swinging 5 degrees, 37 minutes. Okay, so it's asking, what is this arc length right here? And what we need is the entire angle measurement for this right here. So it's going to be 2 times this right here. And then we are going to use our arc length formula. The S equals R times theta, or radius times theta. Now, remember, to use this formula, you can your theta has to be in radians, but we are given degrees minutes. So what we're going to have to do is change that whenever we are working our problem out. So R is equal to our 14. Our theta is equal to 2 times the given angle measurement, 5 degrees and 37 minutes. Okay. But theta needs to be in radians. Now, to convert to radians, just remember, multiply by a pi over 180 degrees. I'm just going to plug that all into our problem. Instead of doing it here, estimating that, and then plugging it into our formula over here, I'm just going to plug it in all at once into my calculator and see what I get. So 14 in for R, and in for theta, I'm going to put 2 times my angle measurement, and to turn it into radians, I need to multiply it by pi over 180 degrees, and then plug that all the way into your calculator. And what you should get is something like approximately 2.74, and that is one of our answers. And this is in inches. And we are done. Okay, on this problem, not too bad at all. What we were asked to find, it says the area of a sector of a circle. So you're going to need to look at your area of a sector formula, which is area equals 1/2 r squared theta. And just like the arc length, the theta is in radians, so is this theta here for your area of a sector. So plug in what you know. The r is 11.3, and your theta, which is in radians, if it's not, just remember, multiply by pi over 180, and plug that into your calculator, and your answer is about 20.1. And since this is area, since I'm going over what units of measurements it's going to be, because you may not have multiple choice on all of your questions. So just remember, area, you need to put your unit of measurement given here, but square it, and you're done. The next couple of problems I have here are 15 and 16 that deal with angular or linear speed. So let's take a look at this one. It says this means angular speed for a spoke on a bike tire revolving 85 times per minute. Okay, so what this means is it is rotating 85 revolutions per minute. Okay, so at this point, if you want to find angular speed and you are given revolutions per minute, the only thing that you need to do at this point is multiply by 2 pi, because that's how many radians are in 1 revolution. Okay, so here revolutions go away, and we multiply 85 to 2 pi, and it looks like here and all of our answers are in the form with pi still in the answer, so as a multiple of pi. And what we get is 170 pi radians per minute, because radians per minute. And that's your answer right here. Okay, number 16 deals with angular, or not angular, but, well, it has angular velocity in it, but we're asked to find the linear speed of something. So here we have a wheel is rotating at 5 radians per second, and the wheel has a 32-inch diameter. It's important there. To the nearest foot, what is the speed of a point on the rim in inches or in feet per minute? Okay, this one is actually not so bad in calculating the linear speed, but you have some converting to do because you are given inches here for the radius or the diameter, and then this is in radians per second, but it wants our answer to be in feet per minute. So let's go ahead and just calculate this linear velocity. Now you will have these formulas. The linear velocity is equal to, there's several formulas for it, but use the one that you applies most to what you're given. And this right here, radians per second, that is your angular speed. Your angular speed is always going to be measured in radians per time unit of whatever it is, seconds, minutes, hours. Okay, so 5 is your angular speed. And then 32 inches, that says diameter, but you need radius. So divide that diameter by 2, and you've got your radius, just 16. And then what your units of measurement here, after you multiply these two values together, is in inches per second. Because remember, if you multiply radians to some other angle or some other measurement, like feet or inches or something, the inches or feet override the radians. You do not have to say 80 radian inches per second. It's just 80 inches per second. Okay, now convert at this point. You have 80 inches per second, but you need it in feet per minute. So there is 1 foot in 12 inches. Okay, that's going to get rid of our inches here. And then I'm going to keep on doing this. I'm going to multiply it by, so how many minutes or how many seconds are in 1 minute? Well, 60 seconds are in 1 minute. So that gets rid of our seconds here. And multiply all the way through, and we get 80 times 60 divided by 12, which is 400 feet per minute. And we are done. Okay, on this problem, we are asked for this function here, find the amplitude, period, vertical translation, and phase shift. Okay, so let's go ahead and get started on this one with, I'm going to remind you, when you have a problem in this form right here, sorry, I'm laughing at something going on in the background here. Let's see, bx plus, I'm going to call this c. Okay, whenever you have something in this form right here, either a sine function or cosine function, all of these things are going to be the same, the way you found all 4 of these. Okay, D here is going to help us in finding our vertical translation. So our vertical translation is D, and depending on its sign, whether it's positive or negative, it'll tell you whether you're moving it up or down. So vertical translations, I want you to state the number and then like say D or some number of units and state either up or state down. Not both of them, one or the other. And then for A here, A gets us our amplitude. So amplitude is equal to the absolute value of A. So if A is negative, it's the absolute value of it, okay? That's it. And then for your period of your function, that comes from B. So period comes from this right here. I'm going to state it's 2 pi over B. So reduce that fraction or whatever it is that you have there, and you're good for that period. And then for C, that helps us in getting our phase shift. Before I've told you how to find the phase shift is just take that, solve for 0, and you've got your phase shift. Well, that works. That works in this case. Going to abbreviate it here, phase shift, PS. You can do that, but let's do this. Ooh, that sign right there is actually supposed to be a negative. Let's put a negative sign here. Okay. And what you're always going to get for your phase shift is it's going to be this number right here divided by this number here. So you could just remember that it's C divided by B. Okay. And depending on its sign here, what this sign is here, just remember up here, if you have a minus sign, then your phase shift is causing the whole graph to shift to the right, and how many ever units you calculate here. And then if this is a plus sign, it's going to the left. And just like vertical translation, I want you to state that. Either this many units to the left or to the right. One or the other. Okay, so let's do that with this problem here. For the vertical translation, I can get that one right off the bat. It is this right here. So that I'm going to say it's not negative so many units up or down. I'm just going to say 3 units down. Okay, and then for the amplitude, just going in order here. Not this order, but the order I'd stated them here. It's the absolute value of A, which it's positive anyway, so we have amplitude of 3. And then the period of our function, I'm just going to state it as P, is equal to 2 pi over B. So 2 pi over 2. So that's our B value right there. And reduce that, it becomes pi. And then our phase shift. So phase shift, and that is equal to this value divided by 2. Okay, so 6, or pi over 6 divided by 2. Reduce that. That becomes, and don't divide 6 by 2. That's not the way you divide these two fractions. This is like saying pi over 6 divided by 2 over 1, which, remember, you take your numerator and multiply it by the reciprocal of the denominator, and you get pi over 12, and this is units to the left. So pi over units. Okay. got my little s here. There we go. And we're done with that problem. Okay, for this problem, we are going to, what does it say? It asks us to, hold on here. Okay, so it says our functions graphed are in this form here. They're either in y equals a tangent, bx, or in the form y equals a cotangent, bx. And so determine the equation of the graph from just the graph itself. Okay, so I have over here ready for us. You will not have this on the test. To help us tell the difference between tangent and cotangent is this right here. Remember, tangent graph will cross through the origin, okay? And then the cotangent, the y-axis is an asymptote on it, so it will not cross through the y-axis, excuse me, at all, especially if there's no phase shift on it, which both of these functions, it's saying from the beginning, there's no phase shift. Okay, so on 18, it looks like we have a cotangent function. All right, so we have a cotangent function, and let's go and find some values on those, what the a and b value are of these. And the way you find your value of a on this function here is here is one full period at this little line that I just dotted here. A quarter of the way through, just a little estimate here, you can draw upwards to your graph and you can see that that quarter of the way through point is at 1. That is what your value of a is going to be. So in this case, a is 1. And then how you get your value of b, same way as we do our sine and cosine functions, we determine what the period of the function is and find it from there. But if you remember, your period of your function for a tangent and cotangent function is equal to not 2 pi over b, but pi over b. So to find the value of b, our period of our function, one full period, meaning just the first portion, that the distance of the first portion that repeats itself over and over throughout the graph is this right here, and it ends at pi over 2. So from 0 to pi over 2, that length is pi over 2. So you can see that the value of b here, if we solve this, is equal to 2. Now we have our equation. We discovered already it's a cotangent function, and we have a and we have b. We just simply need to write everything in. So 1 times cotangent of 2x. And that's it. Now on number 19 here, we can see that we have a tangent graph, but because it goes through the origin, but it's upside down in it. See, it's a decreasing function rather than an increasing function. So in this case, what we're going to do, our value of a is going to be a negative something. So let's go ahead and put a negative on it. But let's figure out our value of a. Let's look at this right here. This is one of our amplitudes, and our other amplitude is going to be over here on this side, just a little bit away from that. This is pi over 4. This is pi over 2. Sorry, I drew that line very badly. This is negative pi over 2. This full distance of one full period goes from negative pi over 2 to 0 to pi over 2. It goes all the way through. So calculate that distance all up. We are going to say pi over 2 plus pi over 2. Well, that's just pi. That is one full period of our graph. So we can set what was it? Pi, that's our period, is equal to pi over b. That helps us find our value of b is equal to 1 because of this right here. There you go. Now let's find that value of a. Remember, go to the quarter of the way through points, and you would see this one full period. Here's a quarter, halfway, another 3/4, and then a full period. Halfway point, if we draw upwards, well, let's see. What did I say? Okay, let's draw upwards. As straight of a line as I can on this thing. It looks like we're here at 4. So our value of a is going to be 4, but it's also negative. So there, put it together. It's a tangent function, a negative 4 value for a and 1 for b. So I'm going to write that up here. Y equals negative 4 tangent of 1x. And we're done. Okay, on the secant and cosecant graphs, that's what is being graphed on both of these numbers here. It's not stated in your directions. I'll try to remember to put it in there after I get done with this thing. But just like the tangent and cotangent graphs, I am not going to put any phase shifts or vertical shifts, at least I don't think so, on these graphs. So it is going to be in the form of this here. It's going to be a pin out. It's going to be in this form here or the other. And a times cosecant of bx or y equals a times secant of bx. Okay, so let's take a look at secant and cosecant functions, what they look like. Here is a cosecant function. It does not go through the y-axis at all. It's actually a vertical asymptote, just like in the cotangent function. And then the secant graph, it goes through the y-axis. And remember, this is only when there's no phase shifts. Those are true of what I just stated. Okay, now let's look at 20 and 21 and compare it to these graphs over here. If we look at 21, it looks a lot like this graph here, except a different portion of it is being graphed. We're only seeing what's on the right side of our graph. But here, it is a cosecant function. And let's see, I'm going to go ahead and draw out this right here from our y-axis to this line here. That is one full period of our function being graphed, because after this point right here, we're going to continue with a u this direction and then a u going down this direction, and then it keeps going and repeating that same pattern. So this right here is our first full period of our function, and I'm going to go ahead and solve for our b. Let's see. And remember, secant and cosecant functions is just like sine and cosine. Our period is equal to 2 pi over b. And our period for this function is pi. And let's see, when we solve for b, we get b is equal to 2 pi over pi, which is just 2. Now our graph, it's not being like in the previous exercise, one of the tangent or cotangent functions that we looked at, it's not flipped upside down. It looks just like this function here. So it's not negative. Our value of a is not negative. And our value of a, how we're going to find it, is the distance between the x-axis and our minimum value, or the distance between the x value and our maximum value. It should be the same. But this distance is 1, so that's our value for a too. Let's write out this. Our value of a equals 1. We're going to have a cosecant function of 2, because that's our b, x. And we're done with that one. All right, 21 here. It looks like we have a secant function here. And let's go ahead and determine its one of its full periods. Well, let's go ahead and determine the value of a. This goes by ones. The distance between our x-axis and the minimum value is 1. So our a value equals 1. And our value of b is determined by our period of our function. Let's start here at this y-axis here. And one full period ends right here at 4 pi. See how we have this portion of the graph, this portion of the graph, and then that, and then it keeps repeating itself over and over at that point. So y equals, oh, sorry, we need to find b. Period equals 2 pi over b. Our period of our function is 4 pi, which equals 2 pi over b. And that will give us b equals, well, switch the 4 pi and the b around, and we get b is equal to 1/2. So our function is equal to 1 times the secant, because this is a secant function, of 1/2 x. And we are done with that one. And that's all the graphing that I am going to give you on this test. Okay, this is a verifying identity, or verify the equation is an identity problem. And I'm just going to get with it. Okay, let's do it. What we need to do on this problem here is simplify the complicated side down to make it look like this here. So definitely the left side of this thing is the more complicated one. And how I want to start this one out is I can see right off the bat that we just need to put them together, add them, which means we need to get a common denominator. Okay, so both of our denominators are not like one another, so we just need to multiply them together to get a common denominator. Okay, so this one does not have a secant, or 1 minus secant, so let's multiply it by 1 minus secant in both numerator and denominator. Okay, this one does not have a tangent in its denominator, so multiply both numerator and denominator by tangent of theta. Okay, so what we get here is 1 minus secant theta squared plus tangent squared all over 1 minus secant theta tangent theta. Because 1 minus secant theta tangent theta, and then same here. Okay, now what we need to do is let's multiply this out. And remember, it's not just 1 squared minus secant squared theta. That's not it. Remember that this is the same thing as saying 1 minus secant theta times 1 minus secant theta. Foil this thing out. Okay, so that's what I'm going to do. Here we go. We got 1 minus 2 secant theta plus secant squared theta, and then plus the tangent squared theta. And I'm going to keep the denominator in its factored form. I'm not going to distribute the tangent throughout. Not yet anyway. Let's see if we can cancel either one of these factors out with each other. Okay. Next step is what I'm going to do is I'm actually going to use the fact that this right here, tangent squared theta, and 1 plus tangent squared theta is equal to secant squared theta. That is a Pythagorean identity. And I'm going to replace that 1 plus tangent squared theta with a secant squared theta. So what I have here is 2 secant theta plus secant squared theta plus secant squared theta all over, again, same denominator, not changing it yet. Now let's combine like terms. We have a secant squared theta and a secant squared theta, so we have 2 secant squared theta. This denominator thing writing is getting monotonous. There we go. Now, there is something in common between these two terms. We have a 2 in both of them, and we also have a secant. See, we have a secant here, and we have a secant squared here. So let's take away one of those. So let's factor out from here a negative 2 secant theta. That's what I'm going to factor. Factor out this. And when I do, what I'm left with from my two terms here is a 1, because negative 2 secant squared theta is this right here, minus a secant theta. Now, if you don't see what I just did, I just reverse distribute what I did. If I distribute this back through, I would end up right back where I started from right here. But I wanted to factor it because look at my denominator. I have a 1 minus secant theta in it. That can cancel out. So that's what I'm going to do next, is cancel out the common factors. And now I have negative 2 secant theta over tangent of theta. Now change both of these into, we're getting so much closer to this up here, negative 2 cosecant theta, because we now almost got it down to one single term here. The negative 2 secant theta is same thing as negative 2 over cosine theta. And tangent, if you remember, is same thing as sine over cosine. Well, we have common things that we can cancel out. So we got negative 2 over sine theta, which is the same thing as negative 2 cosecant theta. And we're done because it's equal to that. Okay, let's do another one of those verifying identities. This one right here, we are going to reduce definitely the left side of the equation to make it look like the 2 sine squared theta. Okay, so let's look at it. What I'm first going to do, because we have this plus 1 over here, is I'm going to get a common denominator between the two of these things. So I'm going to say 1 minus cotangent squared theta over 1 plus cotangent. Oh, that's supposed to be a plus. Plus this 1, same thing as saying 1 plus cotangent squared theta over 1 plus cotangent squared theta. Sorry, my handwriting is terrible on this thing. But anyway, that's your value of 1, but we have a common denominator now. So that is equal to 1 minus cotangent. Let's put the numerators together. Theta plus 1 plus cotangent squared theta all over 1 plus cotangent squared theta. Okay, looky here, we have a negative cotangent squared theta and a positive 1. That just becomes 0. We have a 1 plus a 1, which is 2. And then this 1 plus cotangent squared theta, if we use our Pythagorean identity, 1 plus cotangent squared theta is equal to cosecant squared theta. So I'm just going to take this denominator, replace it with this here. And that is practically this up here, because the inverse function of sine is cosecant. So we have 2, not cosecant, sorry, sine squared theta. And we're done. Okay, on this problem here, it says find the exact value of the expression using the provided information. So we are asked to find sine of s minus 1, cosine s minus 1, tangent of s minus 1, given these two values right here and what their quadrants are. Well, on this, I've noticed some of you think that sine of s minus t is the same thing as sine of t minus sine, or sorry, sine of s minus sine of t. This is completely wrong, okay? You need to follow your identities for sine of s minus t or s plus t. Same thing goes with, these are called your, sorry, I just forgot the name of them, your sum and difference identities, okay? So I think I have those here somewhere. Yes, right here. Sum of two angles and differences of two angles, right here. And how the sine of two angles that either add or subtract together, what it's equal to is this right here. So right off the bat on these problems, do not get like the distribution process confused with what it's actually equal to, because sine is not being multiplied to these two angles here. Sine is a function of these angles. They can't be separated as like in a distribution process at all. You've got to use your identities, okay? So let's go back to this one and erase that. So what we need to do is this right here. So I'm going to say, let's go ahead and write our sine of s minus t, our identity out. Sine of s minus t is equal to sine of s times cosine of t minus cosine s times sine of t. What we are given so far is cosine s is negative 1/6. Cosine t is negative 3/5. And what we need to find, because we have cosine s, we have cosine t, we do not have sine s, we do not have sine t. We need to find those two values. And those two values are going to be valuable for finding this value of cosine of s minus t also. So we just need to find it, find those two. So on the sine of s, I'm using my Pythagorean identity, and I'm going to state it is equal to either the plus or minus square root of 1 minus cosine squared s. Okay, and since we are in the third quadrant, sine and cosine are both negative in the third quadrant for s and actually for t, because we're in the third quadrant for t also. So what you want to do is plug in your negative 1/6 in for cosine, square it, and remember, when you square a negative value, it becomes positive, so still inside here. This minus sign stays minus, does not change to plus. So 1 minus our 1/6 squared. I'm going to take the square root of it, and this is going to be a negative value. I'm going to take away the positive because we only need 1. And once we put the 1/6 in there, let's go ahead and do it. All of that is going to be equal to negative square root of 35 over 36, which is square root of 35 over 6. So that's our sine of s value right here. That's going to be plugged in right here. Now let's find our sine of t from our given cosine t value. I'm going to try it right here. Our sine of t is equal to plus or minus, which in this case is going to be minus the square root of 1 minus our cosine t value, negative 3/5 squared. Sine t is equal to negative 4/5. That's what all of this reduces to. So there we go. Now we got the sine of t value to plug in for here. So plug away. We have sine s is equal to negative square root of 35 over 6. We got cosine t is equal to negative 3/5 minus our cosine s, that's our negative 1/6, and then a sine t is negative 4/5. Multiply and subtract these numbers and put it over the same denominator. We get 3 square root 35 minus 4 all over 30. And we're done with finding sine of s minus t. Now to find cosine of s minus t, we do it in the same way. We use the identity for cosine of the difference of two angles, which breaks out to this. Cosine s times cosine t plus sine s times sine t. Now plug in these values. Cosine of s is, let's see, your negative 1/6. Cosine of t is your negative 3/5. Your sine of s is, let's see, negative square root 35 over 6. And your sine of t is negative 4/5. Just like you did up here, multiply, subtract, or add, and we get 3 plus 4 square root 35 all over 30. Okay, now our tangent of s minus t, we're going to just apply the property or the identity that tangent is equal to sine over cosine. So sine of s minus t, we've got that value right here, and cosine of s minus t, we've got that value. Plug those in, and I'm going to kind of create a shortcut. I know that my 30s are going to cancel out here, so we're going to get 3 square root 35 minus 4 over 3 plus 4 square root 35. Now, on this, I know this is probably a complicated step, but I want you to do it anyway. You will get the majority of the points if you get this step right here on the test, but if you go a step further, you'll get the rest of it. The next step is to rationalize this denominator, and how you rationalize this denominator is by multiplying both numerator and denominator by the conjugate of 3 plus 4 square root of 35, which is going to be 3 minus 4 square root 35. And when you do that, I'm just going to state what it is. It ends up being this right here. 25 square root 35 minus 432 all over negative 551. And there you go. That's your final answer. I will try not to make things as complicated and huge numbers as this, but I can't make any promises on the test. It's generated. So there you go. There are all of your solutions to what we were asked to find in this question here. All right, this problem number 29 isn't so bad at all, but for some reason a lot of you missed it on this last test that we had on chapter 5. This uses the double angle identity for cosine, and I know there's 3 of them that you can choose from, but you need to choose the appropriate one to be able to find sine theta. There is one of the identities of this function here that says cosine 2 theta is equal to 1 minus 2 sine squared theta. I know there's one that says sine squared theta minus cosine squared theta, something like that. You don't want to use that one because it has a cosine in it. You only want the one that has a sine in it because that's what you're solving for, sine theta. And this right here, again, I'll kind of totally miss the point that this right here, negative 3/8, is equal to 2, or cosine 2 theta. That means I can plug this value into this whole thing right here. Negative 3/8 is equal to 1 minus 2 sine squared theta. Solve for sine, just like you've done with your Pythagorean identities and other sorts of identities. Solve at this point. So subtract 1 from both sides, divide by negative 2, and you will end up getting 11 over 16 is equal to sine squared theta. Take the square root of both sides of your equation to get sine by itself, and we get sine theta is equal to the plus or minus square root 11 over 4, but we have theta right here is between pi over 2 and pi, which means that that is the second quadrant, and sine is positive in the second quadrant, so there we go. Sine of theta is equal to square root of 11 over 4. And we're done with that one. Okay, so on this problem here, again, we're going to be using our double angle identities because we're asked to find these values. Sine of 2 theta, cosine 2 theta, and tangent of 2 theta. Now on the test, I may not ask you for all three of these. I may just ask you for one. But if I ask you for tangent of 2 theta, you might as well find sine and cosine. Okay, so these are the identities right here, the double angle identities. And in our double angle identities, if you're asked to find sine of 2 theta, you need to have the values for sine and cosine. So let's go ahead and find the one we do not have, which is cosine. This right here that I'm about to write is just the Pythagorean identity solved for cosine. And this right here tells us tangent of theta is negative, and we have a sine value that's positive. So this means we are in the second quadrant, and cosine is going to be negative. So figure out your sine for your cosine function. And now plug in 2 square root 2 over 3 in for sine. Oops, there's a 2 here. And then square. Find that value out, and it is equal to negative 1/3. Now use the fact that we know sine is this over here, 2 square root of 2 over 3, and cosine is negative 1/3. And plug into your double angle identities to figure out what they are equal to. So sine of 2 theta is equal to, this is the double angle rule here. Okay, and we're going to plug in our sine value right here, 2 square root 2 over 3. Our cosine value is negative 1/3. Now that is equal to 4 square root 2 all over 9. Oh, and it's negative. Now let's find the cosine of 2 theta. Okay, we could have found it with just the fact that we know sine of theta, but there's 3 of them. Choose which one you want. I am choosing that cosine 2 theta is equal to 1 minus 2 sine squared theta. Now plug in sine into your sine squared function. And square that. And that is equal to negative 7 over 9. Now for the tangent of 2 theta, you can use the fact that, yes, it is equal to this right here. And you can find tangent from the sine and cosine values that you have, and then plug them in here. But since we already know that sine of 2 theta is equal to this, cosine 2 theta is equal to that, then tangent of 2 theta is equal to sine of 2 theta over cosine 2 theta. And that is equal to, whoops, let's say that's a 4. I'm going to erase that. negative 4 square root 2 all over 9 divided by negative 7 over 9. The 9's cancel, and we end up having a positive value of 4 square root 2 over 7. And we're done with that problem. I have a couple more problems for you. All right, we're almost done with this thing. Let's see what we have next. We have a problem that deals with the half angle identities. Oops, sorry about that. We're asked to find the values for sine of theta over 2, cosine of theta over 2, and tangent of theta over 2. Again, like the last one, I may not ask you to solve for all three. We don't have a whole lot of time for us on that test, so I don't want y'all going over 2 hours. Definitely want y'all to stay under the limit. But here it says find these values given that we know sine of theta is equal to negative 3 over 5. Now, with the half angle identities, it is nice to know what our cosine value is, because let's see, sine of theta over 2 is equal to all of this with cosine in it. Same goes with cosine of theta over 2. There's cosine. And then tangent. Let's see, there we go. Oh, whoa. Wait, this identity sheet has more than our book. But anyway, see, it uses cosine several times. Okay? So, if you don't know cosine, find it. That's my point here. And we don't know cosine, so we need to find it. Now, let's see what we need to do here. We got to find this right here. It's either going to be plus or minus, and we'll figure out which one it is. This right here. 1 minus sine squared theta. And let's figure out plus or minus. We are in the fourth quadrant here, so cosine is going to be positive. So 1 minus the inside of that radical of, let's see, negative 3/5 squared. That is equal to, see, all of that is equal to 4/5. Okay. Now, the next thing I like to do on finding values of our half angles is take this right here, divide everything by 2 to figure out where our half angle lies, what quadrant our half angle lies in. So 270 divided by 2, that's 135. And then 360 divided by 2, it's 180. Okay, so 135 to 180, that is in our second quadrant. So theta over 2 is in quadrant 2. This was quadrant 4. Okay, now that we know where our half angle lies, because all of our half angle identities do require us to figure out whether it's going to be plus or whether it's going to be minus. So that's why I wanted to go ahead and find out what identity, where our half angle lies. Okay, so let's start with sine. Sine of theta over 2. Our identity says it's equal to the plus or minus the square root of 1 minus cosine theta over 2. Now, since we are in quadrant 2, our sine value is going to be positive. Okay, so we're going to just keep the positive of this and say it's equal to 1 minus our cosine value that we found, 4/5, over 2. And now that is equal to the square root of 1 over 10, which, rationalize it, is square root of 10 over 10. And we're done with that one. Now let's find cosine of theta over 2. It's a lot like the sine of theta over 2, except on the inside here we have 1 plus cosine of theta all over 2. Now the half angle, since we are in quadrant 2, it's going to be negative. So negative square root of 1 minus 3/5. Oh, not 3/5, 4/5. So it's plus, sorry, plus 4/5 over 2. And that's equal to negative 3 square root 10 over 10. Okay, I'm just reducing all of this in here and figuring that up and rationalizing it to get to that part right there. Now, just like the last one, if I ask you these previous ones, tangent of pi or theta over 2 should be pretty easy to find. We just need to divide these two values, or sine over cosine of theta over 2. Tangent theta over 2. Otherwise, if you don't know these two values, if tangent's all you have to find, you might want to just find tangent of theta over, or sine of theta over 2 and cosine of theta over 2. I don't care the way you do it, just find it. But here's some tangent identities for the half angles. Pick one and use it to help you in figuring it out. Oh, wrong one. Okay, so here we go. It is the square root of 10 over 10 divided by negative 3 square root 10 over 10, which ends up equaling, this cancels out, we get negative 1/3. And we're done with that one. Now I only have two more. Now these you are asked to read the directions. For the first one on 32 here, you're asked to write the product as a sum or difference of trigonometric functions. This means you're going to use the product to sum identity. So go to it. Product to sum identity. There it is, right here. Whoops. Right here. Product to sum. And we were given two cosine values that are being multiplied together. So it's going to split out like this. Here, hold on, let me zoom in on that. So that's really tiny. There it is. There we go. And so we're going to use this one right here. And the only thing we need to do in this is plug in our angles that we were given, our A's and B's, or alphas and betas, into here and here, subtract them, and simplify it as much as you can, which there's not all that much simplification in this type of problem. Let's go back here. So this here, using the correct identity, let's see, cosine of A times cosine of B ends up equaling 1/2 of cosine of A minus B plus cosine of A plus B. Okay, that's our identity. And in this case, our A and our B are going to be 26 degrees and 13 degrees. So this is equal to 8 stays on the outside times our 1/2. Let's see, cosine of our first angle, which is 26 degrees, minus our second angle, plus the cosine of our first angle, plus the second angle. Now, like I said, reduce as much as you can. So this right here reduces to 4. And then the inside of our cosine function here will give us 13 degrees. And the inside of this function ends up giving us 39 degrees. And that's as much as you can go. Unless you want to distribute this 4, that's it. I don't require you to distribute the 4. You're done at this point. Do not try to add together or subtract these values right here. They are two unlike terms because they have different angles on the inside of our cosine functions. Okay, so we're done at this point. This is our solution. Now let's do something similar to this problem here. And this is asking us to rewrite the following as a product of trigonometric functions. So right now, it's a sum of trigonometric functions. So we need to use our sum to product identities. That's down here. Here we go. So we have two sine functions being, I can't remember, added or added together. And what we're going to do is very similar to what we did on the previous problem. This is one of our angles. This is another one of our angles. We're going to plug them in here and reduce on the inside of our parentheses as much as we can, and that's it. Okay? Let's do that. Oops. Go here. There we go. So this right here ends up equaling, whoops, that was a terrible line. 2, because that's part of our identity, 2 times sine of our first angle plus our second one divided by 2 times cosine, because 2 sines added together give us this identity. It gives us the 2 sine of first angle plus second angle over 2 times cosine of second angle minus the other angle over 2. Okay, let's see, 9 minus. And then reducing each of what's inside of those parentheses. I'm just going to put in a decimal form. I guess it is an exact decimal. It's 0.5. And the cosine ends up being negative 17.5. At this point, you're practically done. The only thing that I ask you to do is, at this point, is do not leave any negative angles on the inside of your sine or cosine functions. So use your negative angle identities and rewrite this. So if you had a negative angle on the inside of a cosine function, it's the same as just your negative angle identity for this right here is equal to the positive cosine of theta. Now if it was sine of a negative angle, it's equal to the negative sine of theta. So if we had a sine theta here, we would end up putting a negative all on the outside of that function there, or that expression, sorry. Now, just rewrite it as this. Where 17.5 is positive. And you are done. Okay, and we're actually done. That was the last problem of that review that I gave you. But I do want to remind you that the stuff from chapter 7 is going to be on your final. So solving some triangles, you're getting some good practice in on the take-home test that I gave you. So complete that, turn that in Monday, along with any homework that you may not have turned in on Monday for me. And I am done with this review video. Thank you guys for being such a good class, and I will see you on Monday and we will take our final. Goodbye, everybody.